Now, I've got two more substitution style problems on the board for you. And I'm going to work through them both. They follow exactly the same procedure. This one just has a slight little twist in it that I want to make you aware of. So this one over here. Now, substitution, we find things of equal value. Have a look here. This statement up here says 3x plus 5 must be equal to y. 2x plus 9 is also equal to y, so therefore, if the y's are equal, these statements here are also equal. If you want to get mathematically correct about it, we would say that equation 1 is equal to equation 2. And I name the equations 1 and 2 over here. So because they're equal, these components are equal, therefore these components are equal. So therefore we can say 3x plus 5 must be equal to 2x plus 9. Simple algebraic manipulation. You've been doing this style of problem since about grade 8. Recombine the x's on one side and the constant numbers on the other. We now have the x coordinate of where these two straight lines intersect each other. So we find the y coordinate. We have two rules up here for y. It doesn't matter which rule that we use. Rule 1 or rule 2, it will return the same answer. So I'm going to use the first rule. Here it says take my x value out and substitute in what I know it to be, and then evaluate. So once I've evaluated, I now state my answer. The simultaneous solution is found at the point 4, 17. Very good. Let's see what question number 2 looks like. So on this one, the difference in this was that one lot of y is equal to, one lot of y is equal to. But this one looks a bit different. We can still do substitution very easily on this, because every way you see the unknown value y, it has the same value all the way through the question. So this particular y here has exactly the same value as that particular y there. So what I'm going to do is I'm going to take that particular y out, and just like in sport, I'm going to do a substitution. Take one player out, put another player in to do exactly the same job. So now, reading from left to right, I can now say that I'm going to use equation 2. So what I'm doing is I'm going to substitute my results from equation 1 into equation 2 to produce this result. So equation 2, reading from left to right, it says 2 multiplied by. 2 multiplied by what? 2 multiplied by a y value. I'm going to take y out and replace it with its equivalent value, x minus 1. So 2 times y is the same as 2 times x minus 1. Remember to put the brackets in, that's very important. Put that one in your notes, you need to do that. Keep reading from left to right, I have plus 3x is equal to 23. So I've now gone from having equations here that's got 2 unknowns, an infinite number of answers. I've now reduced it down to an equation that has only one unknown, this particular x. It might be in 2 locations, but it's still just one unknown value. Once again, expand the brackets, recombine like terms, and solve as you normally would. You might want to pause the video now, have a go at that, see if you can work out the x coordinate and the y coordinate of the intersection, and see if you agree with my answer. So pause now, have a go and see if we agree. And here is the final solution. The coordinates of the intersection of these two straight lines, they intersect at the point 4.2, 3.2. Didn't come to nice whole numbered answers, and it won't always, so be aware of that. So here I've expanded the brackets, recombine x's on one side, the constants on the other, solve for my unknown, substitute it into here. Now, I am going to add one extra step into this in some later problems. If you did this, I'd be very happy with your work that you come down to that particular solution. But because we're heading towards doing Mathematics B, we need to start stepping this up a little bit. There's one extra step that I'm going to add in on future videos that you will need, and it's called verification. In maths, when we talk about verification, it means, are you able to arrive at the same answer by coming at it from a different pathway? So if you come at your answer one particular way and get a certain answer, attack the problem from a different pathway and get the same answer, you've verified that your solution is correct. So I'm not going to do that here because I just want you to get the idea of how to do substitution for now. But when we start getting on to elimination, I'm going to introduce you to the idea of verification and see where that leads us. Okay, see you on the next video where I start talking about the elimination method.